Is this some kind of record player? There is a long play record and a magic black box. Obviously not, because it makes weird noises, but no music. So, some of you may already have noticed the little holes around the edge of the record and think of a mechanical TV with a Nipkow disc. Didn't you? But it's not that either. I will reveal the secret in this video. Stay tuned. I don't want to keep you in suspense any longer, so I'm going to tell you what it is. It's a mechanical digital camera. And here's how it works. The heart is an old vinyl record into which I drilled 32 equidistant holes. Each of the holes is 1 mm further out than its predecessor, so they sit along a spiral line. In front of the record I mounted the lens of a discarded SLR camera. This projects an image of what I want to photograph onto the holes. If the disc now turns clockwise in front of the projection, exactly one hole always moves through the area that is to be photographed. And because each hole is offset a bit outwards, the image is scanned line by line from top left to bottom right. So each hole scans one line. With 32 holes, 32 lines are scanned per rotation. Sometimes more and sometimes less light falls through the hole, depending on where it currently comes by. In the black box made of black sprayed plywood on the other side we have the collimator lenses from a slide projector. Their task is to concentrate the light that falls through the holes onto a photodiode, which I placed right into the focus point. The student Paul Nipkow came up with this principle already in 1884, but it was not implemented until 40 years later by the Scottish inventor John Logie Baird. He built the first TV sets that implement Nipkow's principle, and from 1930 to 1935, the British BBC broadcasted their TV program in a format that could be received with these TV sets. And this is a Baird televisor in action. It's the opposite of my camera. Instead of a light sensor, there is a flickering neon bulb. If you watch this bulb through the rotating Nipkow disc, you see moving pictures. This is due to the persistence of view effect. Although this method was originally designed for moving pictures, my apparatus works only for still images. This is because photodiodes respond more sluggishly to changes in light intensity the less light they receive. And because of the small holes, the diode receives only a very small amount of light. With this in mind, the photo motifs must be exposed to bright light such as sunlight. Otherwise, it will be hard to see anything but noise in the images. This is why the disc in my camera rotates so slowly. To make it turn, I simply mounted the record directly on the axis of a stepper motor on which I put a piece of aluminium pipe to fit the diameter of the record center hole and keep it in place with 2 drill stops at either side. These motors can be driven at very low speed and be controlled precisely. This is ideal for this purpose. The control is done with a driver module and a Raspberry Pi. When I start the Python program on the Pi, the disk starts to rotate until a special synchronization hole gives way between an infrared LED and a photodiode on the other side. Then the first hole stands at the beginning of the first line of a new image and the shooting can begin. The disc now rotates step by step, and at each step the amount of light that reaches the photodiode is measured, digitized and sent to a Raspberry Pi via SPI. I use the 32 by 100 NumPy matrix to store the values. This is because the camera scans 32 lines, while the stepper motor makes 100 steps per line. At every step, we measure 10 values and calculate the mean value to minimize noise, and store it in the raw data matrix. Using the OpenCV framework, the raw data matrix is then transformed to a black and white image, scaled up to 320 by 250 pixels and displayed on the screen. Believe it or not, but this machine really produces something like photos. Can you tell what's on them? Although the images are black and white, very blurry and distorted, you can actually make out what's on them. Amazing, isn't it? This mechanical camera only works with bright sunlight, has a miserable image quality, and is also rather bulky. I dare to say, this is the worst camera in the world. But it was fun for me to build this thing and share it with you guys. So if you enjoyed this too, then hit the like button. Check out the other videos on my channel and subscribe if you want. Also consider to support the channel through Patreon and get more previews and other goodies. The link is also in the video description. Thanks for watching, see you in the next one.